Hello everyone, good afternoon. I'm sorry I cannot attend the meeting because I need to go to Indonesian representation office in Taiwan to have some inquiry with the government. So I'm going to present my research recently. Uh, this presentation also will present in Hokkaido University tomorrow. So if you have any comment and suggestion, especially for Professor Chang, please let me know. So the title of my articles, my presentation is about the modified physics course significantly improve student scientific inquiry skill. Fee less than 0.05, making meaning of Bayesian inference. So my full name is Dadan Sumardani, and then my research interest is about science education, and then physics education is also my background. I'm from State University of Jakarta in my college degree, and then my research interest also about educational technology. I focus on virtual reality and augmented reality. If you have any question about VR and AR, you can ask me in further discussion. And then my research interests also include STEM education and cognitive neuroscience. In this presentation, I will tell the story of how our lab is adopting Bayesian as our main statistical analysis. Before, traditionally, we often use like p-value, and then we also using only kind of SPSS. In the recent years, we're trying to adopt the new approach we call Bayesian inference. So in Bayesian inference, they are really new, at least in education. Uh, so we have the opportunity to learn with professor in United States, and then we discussed for the last 1 years about that. So I'm going to tell you the story of that. So I remember in 2022, I have the inquiry from Professor Chang to analyze the multimedia-based inquiry assessment, and then inquiry-based assessment that I have is include questioning, experimenting, analyzing, explaining, and then it covers uh, several question, experiment one, and then have two question number 3, 4, and 5. So it is kind of PISA assessment. So it's about multimedia-based inquiry assessment. But in 2022, I trying to analyze the participant data. So the participant data is about 30, 33,000 participants. That is huge number of participants. So at the time, I'm trying to using, like normal statistical power using SPSS. And then I'm trying to compare between school area, school nature, school category, and resident. And then it turned out something really satisfying. It's really satisfying, but in others fields, I think it's getting meaningless. So all parameter that I have is significant. School area is significant, school nature is significant, school category is significant, and resident is also significant. So I say, oh, maybe something wrong here. But although all of them is significant, I'm not satisfying with the data itself. So this is one of the examples. So inquiry test score, gender male and female, mean, well, it's kind of different in mean, but standard deviation also only a little bit different. T-value, they have really good T-value here, but p-value, you can see that is 0.0000. There's a lot of zero. So I say, oh, this is not meaningful. Even my friends, he is mathematician, he say 000 mean nothing. So it's supposed to be 1 somewhere else, but we didn't find any 1 here. So I say it's meaningless. Maybe we need to find some other resources. So it turned out in the next discussion, after I read and then learn something, I heard something about ambient correlation noise and then crude factors, in which it turned out our test to become too sensitive because they have too many participants. In fact, too many participants is good actually. If you have more, it will be good. But in statistic, it's kind of, something wrong. It's supposed to be something wrong. I don't know at the time. So I trying to discuss with Professor Chang at the time. So Professor Chang suggests me to use Bayesian. So Bayesian basically coming from Bayes theorem. I don't know about Bayesian before, but I learned Bayes theorem before in mathematical physics in my college. So basically it's only probability of an event. So for example, if there are 3 people among 10 people, so the probability is 10 divided by 3 divided by 10. So that is the probability of event, as simple as that. So what is the true meaning of V value? I'm trying to asking myself, and then we trying to discuss with Professor Chang, what is the true meaning of V value? It turned out different with um, our belief about V value. So I'm trying to make some reflection of my personal study at the time. So basically I have conduct some research using V value. It published in really high impact journal in SSCI. So I'm using pre-experimental. So quote in my conclusion, I say student who took computational physics course show significantly improve computational thinking. V value less than 0.05, which is really significant difference. And then after that, I think I will commit to implement Bayesian approach in further analysis of my research. Let's say my research, although I already have maybe just put in the bag, and then I try to improve using Bayesian. So I try to learn using RStudio starting from last year. So I'm getting learn more into Bayesian in RStudio. So I'm going to talk about this article. Actually, this article is recommended by Professor Chang. So the title is "The Earth is Round. V value is less than 0.05." It's similar with my title in this presentation. So actually, Cohen in 1994 criticized the V value so much. So why he criticized the V value? Number one is people, educators, researchers is rely on too much ritual on null hypothesis significant testing, which is dichotomy decision on wholly 0.05. We really make it really sacred. And then near universal misinterpretation of P as the probability that null hypothesis is false. And then actually what we want to know in our data is, given this data, because we're collecting a lot of data, given this data, what is the probability that null hypothesis is true? What we want is like that. But in V value is only tell us that given the null hypothesis is true, what is the probability of the data? So although maybe for some people it's kind of similar, in syllogism, in logical thinking is kind of different. Although we have kind of thinking error, so if people have null hypothesis rejection, they will think that replication, which is similar study in the future, will result in similar result. And then number two is theory is established. For example, after null hypothesis is rejection, the theory is established, new theory according to our null hypothesis rejection. And number three is if repeated many times, significant will obtain 99% of the time if V value is 0.01. So there is kind of thinking error in our V value approach. So solution from Cohen say V value only as a direction, which is whether it is agree to the right or to the left. In further discussion, Bayesian, they will more about probability of direction, which is almost similar but have different meaning and then different uh, theoretical framework of it. So they become probability of direction. We can say PD, probability of direction. And then another one, we need to have confidence interval as amount, not only direction. We need to have amount. Like in physics, we have 10 centimeter. In statistical research, we need to have direction and amount. How much to which direction? That is Cohen say we need to have confident interval in our research. And then the next one is correlation coefficient as amount also. So effect size also need to calculate and then put in our research, and then or percent correlation to show some correlation coefficient. And then also the solution from Cohen is to use graphic method. It also really getting more interesting in our era, because before we don't have any good computer, but since now we have a lot of good computer, and then many people, scientists trying to use graphic method, getting more advanced. So that is my question. So is it time to move on from p-value? So I think yes, it is the time. I believe Bayesian will be the future of our statistical research. So in this slide, I will discuss what is our current progress of moving to Bayesian approach from traditional one. So we try to implement Bayesian to all of the research that we have. One of those is SEM. SEM is structural equation model. We try to implement Bayesian to this approach, and then we also trying to adopt Bayesian to t-test. T-test is kind of general statistical and then the easy one in practicing the research. So this is one of the study from my friends, Chirong. This is Chirong study published in 2023, just this year, published last month. So Chirong trying to implement SEM to make some to calculate the probability of direction in each path. For example, from SE to pre-SR, they are 100%, 100% the probability of direction. So the direction is clear to which side, whether agree or not. And then they also mention the median here. Median, as I mentioned before, is the amount, how much the direction it is. And then they also put some 95% credible interval, which is also the amount of the direction. This is one of my study, not yet published, still in review. So I'm trying to implement Bayesian to t-test. So I'm trying to compare between male and female in my statistical analysis, and then trying to compare city, county, and rural. So I'm using Bayes vectors. Is another approach to implement Bayesian. Not only probability of direction, but also we can use BF, Bayes vectors. So in recent research, I also implement Bayesian to multi-level model Bayesian. So the ideas of multi-level model Bayesian is we're trying to understand if they are district level, school level, class level, which one, if we have some problem in education, which one we need to address. So in this case, I'm trying to understand scientific inquiry. If students have higher, if students have lower, which one we need to address, whether district, school, or class. So this is our hypothesized data generating model. So we're trying to fit a normal distribution at the first time, but it turned out it's not good. So you can see the normal distribution is here. This is the ideal one, the ideal one, but this one is our data. So our data is kind of not fit with normal distribution. So the next step we're trying to implement to we call Poisson distribution. So Poisson distribution, it turned out is like similar with our data. So we use Poisson distribution. This one is the step 2. We trying to describe the data plot. So this is the hierarchical and nested structure. This is the diversity in class level, diversity in district level, and then diversity in school level. So we try to summarize which level has more responsible. So we found that district level has more responsible to the level of student inquiry level, which is 0.29. So district level take more. And then we're trying to test. So we found that if we put the level, district, and then school and class, the proportion of the total variability is explained 43%. But if we exclude it, so we only put the score, it's only correspond to only 24% of it. So we also trying to understand if we count as the percentage 100%, which one has more variability in here. So we can see there are much variability in here in district level, but in school and class they are really less. Class is even less than school level. So in discussion and conclusion, we trying to report the ideas of that. So the factors specific to individual classroom, such as teaching style, classroom management, or teaching student interaction, probably have a smaller impact on the variability in student performance compared to broader factors related to district and school. For example, available resources, teaching approach, curriculum, or socioeconomic factors. The study also from Wright in 2012, American public education in suburban area is significantly better than in urban area. It also among district level. So disparity between district and school sectors in education is drastically different due to resources, teacher attrition rate, and lack of parental support, is according to Wright 2012. So the implication of my research is multi-level Bayesian model can help identify area where improvement may be necessary, targeting intervention at different levels to enhance student performance. However, I also noticed some really good research and then some really good uh, suggestion from Flores in 2007. He say, we often see in the article students of color continue to lag behind white student and some Asian student, and so-called academic achievement gap still exists. This term, quote, is blanket statement, which is only the surface of it. We only can see, okay, maybe city is better than the village. But why? If we only cover that one, city is higher than village. They say it's meaningless. They only blanket statement. So blanket statement is kind of sometimes it's dangerous also if we didn't really pay attention of it. So blanket statement about low performance of student group without mentioning the underlying may trigger stereotypical term. For example, you are from village, maybe you are have less blah blah blah, something like that. Stereotypical things. And the general conclusion of my presentation is, I mentioned in the title, the modified physics course significantly improves students' scientific inquiry skill. We cannot use only the upper one, so we need to put like below. The modified physics course significantly improves students' scientific inquiry skill. We need to put direction. Okay, maybe we cannot, maybe some people they hard to move to Bayesian. Maybe you can use p-value, but plus some amount of it, because p value is only the direction. You need to put d as the effect size, as the amount, and then confidence interval also as the amount of it. And then if you are ready to move to Bayesian, maybe you can move and then change p value to PD, probability of direction, plus you need to put some amount of it. So amount and direction need to be coming together. I think that's all from my presentation. Thank you so much.